Assalamualaikum and good morning to my panel and my supervisor Encik Aizan bin Ubin. First of all, my name is Muhammad Farid bin Abdul Razak and metric number CE18106. Today I will present which is herb smart farming system based on IoT. First, we must know what is hydroponic. Hydroponic is the method of growing a plant in a nutrient-rich water-based environment. It comes with a many incredible benefits over traditional breeding. Zero soil, 2 times grow rate, 80%, less water, no weed, nutrient efficient, fewer pesticides. Okay, how hydroponic works? The reservoir is full of the water and nutrient. The root are partially submerged in the water, partly exposed to the air. That means plants are able to take up enough moisture and nutrient for their growth. The plant grow, the plant root absorb the water and nutrient when they grow, leaving an air gap for the respiration. Set it and forget it. After several weeks, plants are ready to harvest it. Okay. This is an adverse effect of hydroponic system. First, requires constant monitoring and maintenance. Second, water-borne diseases because lack of the care. Third, deep knowledge is needed. Introduction. Design and development of herbal smart farming system based on IoT. This project can help a farmer use hydroponic crop method combined with IoT technology to increase crop yield. Moreover, solve the problem of farmer to monitor the condition of the crop via the smartphone. Detect such as pH sensor and electrical conductor EC sensor for a nutrient placed on the plant with the aim of monitoring the condition of the plant to increase productivity. There is a problem statement. Farmer often repeatedly go to the garden in a day to monitor the herb crop. Second, unskilled farmers have a hard time to determine the nutritional content pH of crop that fluctuated regularly during its drill. Lastly, the problem of smart farmer giving a nutrient fertilizer to erratic crop and enable crop nutrient. Okay, this is a objective of the project to build an automatic hydroponic system using IoT ThinkSpeed app to grow herbs. Second, to design a smart herb hydroponic system capable of detect water pH change and electrical conductivity by using pH and EC sensor. Lastly, to verify the functioning of the system with the cultivation of the different plant herbs. Okay. This is a scope of the project. First, we using parameter pH and EC sensor to detect a suboptimal pH and nutrient solution concentration level. Second, balance the concentration of nutrient solution and plant pH by adding a nutrient solution pH to the water solution automatically. Third, use IoT platform which is a ThinkSpeed to store the data. And lastly, to prove the concept of the smart hydroponic, only 3 types of herbal plant will be used. For example, basil, peppermint, and lemon balm herbs. Okay, methodology. Block diagram of the project. This is a block diagram and some component for the herb farming system project. The Arduino microcontroller powered by 5V DC. Ada 5V DC and 12V DC provide the Wi-Fi modular, water pump and pump regulator. A pH sensor is used to detect acidity, purity of water in a hydroponic system. Nutrient 10, whereas an EC sensor is used to detect the concentration nutrient solution. Okay. The Wi-Fi modular serves as link between the project and the user interface. Yes. This is a flowchart process of the project. First, program start. Connect IoT device clock via the Wi-Fi. And this is a main loop. Go to the reading value sensor, pH and EC. Then sensor send a result to the ThinkSpeed. Okay, this is a parameter of the sensor. And this is stage 1. In stage 1, if the EC level is measured below 1.4 and the pH value is measured above 6.6, the system will only compensate by adding nutrient solution. In stage 2, If the EC level is measured above 1.4 and the pH level is measured above 6.6, the system will add a pH down buffer to make the water more acidic. Okay. In step 3, if the EC value is above 1.4 and pH value below 6.6, the system normal condition and run the water pump to the hydroponic rack. Okay. Next, the time to delay 100 seconds and the end. Okay. Next, a circuit diagram. The pH sensor probe was connected to the Arduino microcontroller using a meter board pH. An EU power cord used as a probe EC, and 1 kilo ohm resistor we are used to construct the EC emitter. Then there is a Wi-Fi modular series board. We are connected to the microcontroller RX and TX port to establish a serial communication. Okay. The fluid pump we are linked to the 3 distant circuits so that each pump could be controlled separately. Okay. Next, the result. This system will have the data received from the sensor process can be sent to the IoT platform. Second, actuators such as water pump, solution pump can be used to adjust the system parameter. Okay. Finally, smart farming is integrated with the Internet of the Thing by analyze large amount of data sent from sensor to be able to control avocado crop growing perfectly. Okay. The system was designed to collect data from the sensor and store it central microcontroller before sending it to IoT platform. The Internet of Things platform is capable of storing, analysis, and previewing data for the user through a private public web interface. Okay, this is a figure show the result of smart farming by using website ThinkSpeak. Okay, this is a value for pH, EC, temperature, and ppm. Okay, this design of project. This hydroponic rack, and this pH down solution, and this nutrient solution, this tank of the water solution, and this is a herb smart farming system. Result of reaction test. Figure show the data collected EC value during the reactor test. Okay. The graph of electrical conductivity EC and the action taken by the developer control system to maintain the range. When the EC are far outside of the acceptable range, a highly concentration nutrient solution was injected to the reservoir to bring it back into the balance. Okay. The figure show the data collected pH value during a reactant test. When the pH level reservoir is too high, a pH down solution is injected to lower the pH. The figure shows the despite of graph of pH stability in the system. When the pH of the nutrient solution is distributed and accelerate the necessary range, the system takes action to store the pH level. Result of behavior test. A 10-day test was conducted to assess the system's ability to maintain acceptable parameter and range. The experiment used a 3 fully grown herb plant in a 20-liter plastic container. Then 50 liters of the tap water we are added, and all electrical components we are turned on. The pH will be 7.89 and EC will be 0.6. After 7 days, 2 liters of the water we are add to the water solvent to compensate for evaporation. Every 100 seconds, data was collected. Figure show the result. Data collected pH, EC, and temperature in the behavior test. The table shows the detailed analysis actual situation. The electrical conductivity is 0.6. and pH 7.89 in the morning on the first day. This is because of the water in the tank is tap water which contain no nutrient mixture. State 1 EC less than 1.5 and state 2 pH greater than 3.6 activate the system nutrient and pH stabilization function. In the evening, the water neutral solution return to the state 3. It's a normal state. From the second and 8th day, electrical conductivity decreased due to the herb growth that absorb more nutrient. On the 9th day, pump B will function state 1 to add the nutrient to the water solution with EC value less than 1.5 in the morning. The pH reading increased from 5.7 to the 6.5 the second to the 7th day due the pH change in the water. Pump C is activated state 2 during the 7th day a night to bring the pH back to the normal state, state 3. In state 3, the water pump will pump water solution to the hydroponic rack for a 5 minute on and 10 minute off. Okay. Figure show the result of 10 day growth of the 3 type herbs, lemon balm, basil, and peppermint. Conclusion. The proposed automated control and monitoring system for hydroponic system was shown to be sustainable and renewable. The main tank nutrient solution level is maintained by pH and EC balancing. The proposed system was evaluated at the prototype level and the design demonstrate compatibility and dependability at the large scale, lowering the system scaling across. The pH and EC sensors are reliable with the less error factor. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. It is our prototype project which is smart farming based on IoT. This the hydroponic rack for placing herb plant. This is a tank to store the water before it's pumped to hydroponic rack. Okay. This is a pH sensor and this is EC sensor and this is temperature sensor. Placed in the tank to determine the water content. After that, this is pump A, pumping of water from the tank hydroponic rack. Okay, this is pump B to pump nutrient solution to the tank. This nutrient solution is a mixture of fertilizer A and fertilizer B. Okay, this is a pump C to pump pH down buffer to the tank to decrease the pH reading. Okay, now we run the project. First, we connect the cable Arduino to the power. Okay. Then compile, open the serial monitor. Look at serial monitor, project is running. And this state add nutrient solution. And pH 5.7, EC 0.6 and ppm 306. Temperature is 27 Celsius. Okay, then we open the switch and pump nutrient solution run at the serial monitor state 1 nutrient solution. Okay. The pump work according to a predefined state. Now state is state 1, add nutrient solution. Okay. State 1. If the ECV level is measured below 1.4 and the pH value is measured above 6.6, the system will only compute by adding nutrient solution. Okay. After that, this is a Wi-Fi modular ESP01. Now running to sending data pH, EC, and temperature reading from the sensor. We can monitor the data from the website. We open the website hydroponic, ThinkSpeak, and okay, we get the result. The data for this EC value, we get 1.51 and ppm 981, and this is a pH value 3.99, and this is temperature value 27.9 Celsius. Okay. Then we can also use a smartphone to monitor the data. We can use ThinkView. We click the Smart Hub hydroponic system. Okay, we get the result same as using a website review. We can compare. This is a EC value 1.65, same EC value from the ThinkView 1.65. Then pH value, we get 4.08, and this is ThinkView 4.08 pH. Okay, that's all. Thank you.